Learn like a pro.
All right, let's dive right in. Today, we're exploring the incredible world of electromagnetism. We're going to see how we take a totally invisible force of nature and engineer it into a powerful, practical tool, one that you use every single day, probably without even thinking about it. And it all boils down to this one question. How does an invisible force, something born from the electricity flowing through your walls right now, act as a silent guardian, literally preventing house fires every single day? By the time we're done here, you are going to know exactly how. And the whole thing starts with a deep connection between two of nature's most fundamental forces. So, our journey starts at the very beginning, at the birth of the magnetic field itself. You see, electricity and magnetism aren't just related. They're practically two sides of the exact same coin. Okay, so check this out. This is the absolute core principle of everything we're talking about. Anytime you have an electrical current, and that's really just electrons zipping through a wire, it automatically, spontaneously creates a magnetic field around it. It's just a fundamental law of physics. No current, no field. Flip the switch and poof, a magnetic field just appears out of thin air. Now, this field isn't just some chaotic mess. Oh no, it has this beautiful, orderly structure. For a simple straight wire, the magnetic field forms these perfect concentric circles around it. You can almost think of them like invisible ripples in a pond, with the wire right at the center. And just like those ripples, the field is strongest right up close to the wire and gets weaker and weaker the farther you move away. So you might be wondering, okay, great, circles, but which way are they spinning? Well, physicists came up with this really handy trick called the right-hand grip rule. It's super simple. Imagine you grab the wire with your right hand. If you point your thumb in the same direction the current is flowing, your fingers will naturally curl around in the exact direction of the magnetic field. It's a brilliantly simple way to visualize this totally invisible force. Okay, so a single wire makes a field. Awesome. But let's be honest, that field is, well, it's pretty weak. To make it truly useful, we need to find a way to concentrate that force, to really focus its power. And it turns out, a simple change in shape can completely transform the entire system. So what happens if instead of a straight wire, we coil it up like a spring? This shape has a name. It's called a solenoid, and it's a total game changer. You see, each little loop of the coil is still making its own little circular field, but now they're all lined up. They merge together, they reinforce each other, and they create one big, powerful, and super focused magnetic field that runs straight through the center of the coil. It ends up looking almost exactly like the field from a classic bar magnet. And this table really sums up the difference. With a straight wire, you get this weak, spread-out circular field. But with a solenoid, bam, you get a highly concentrated, powerful field right down the middle. Even our right-hand grip roll gets an upgrade. For a solenoid, it now tells you which end is north and which is south. The big takeaway here? Shape is everything. So we shaped the field, we focused it, but here's where the real engineering comes in. The magic isn't just having a magnet. It's having a magnet that you can actually control, one where you can turn the strength up or down whenever you want. And that leads us to the next big question, right? We've managed to concentrate this magnetic force, but how do we get a say in how strong it is? How do we turn this simple coil of wire into a truly engineered, controllable electromagnet? Well, the answer is right here. Think of it like we've got this strength dashboard with three main dials we can tweak. First, we can change the current. More current, stronger magnet. Simple. Second, we can change the number of coils. More turns of wire, stronger magnet. And third, we have our secret weapon, adding something called a soft iron core. And you can see the difference right here. It's not a small change, it is absolutely dramatic. On the left, you have our basic solenoid. On the right, we've just slid a piece of soft iron inside. The field gets massively amplified. This isn't just a little boost. It's like adding a turbocharger to our magnet. So why soft iron? What's so special about it? Well, it's not soft like a pillow. It's magnetically soft. And what that means is it becomes an incredibly strong magnet when you turn the current on. But the moment you turn the current off, it almost instantly loses all of its magnetism. That on-off capability is absolutely crucial for control. A permanent magnet would be on all the time, which would be totally useless for what we need. Okay, so now all the pieces are on the board. We've got a force we can shape, a force we can concentrate, and a force we can control. Now let's go back to that question from the beginning and see how this all comes together inside that household guardian we talked about, the circuit breaker. And here it is, the humble circuit breaker.
You've probably seen one in your basement or a utility closet. It just looks like a simple switch, right? But inside that plastic casing, its mechanical brain is the very same smart electromagnet we've just been designing, and it is constantly monitoring the flow of electricity, just waiting for a signal.
So, how does it actually do its job? Well, it's this really beautiful and simple four-step sequence that goes from everything being fine to a life-saving break in an instant. Let's walk through it.
Step 1, normal conditions. Everything's fine, you're making toast, watching TV, electricity is flowing through your house and through the coil of our electromagnet. Now, this does create a magnetic field, but because the current is at a safe, low level, the field is just way too weak to do anything. You can see the little iron bolt is just sitting there, locked securely in place. All is well.
But then, something goes wrong. A fault, a short circuit, whatever it is, suddenly a massive, dangerous surge of current rushes through that wire. And what happens when we crank that current dial all the way up on our electromagnet? It becomes a powerhouse. Instantly, it's strong enough to violently yank that iron bolt right out of its catch. It's like a magnetic tripwire, and it's just been triggered. And that's the final piece of the puzzle. The very second that magnetic force pulls the bolt free, a compressed spring that's just been waiting under tension is finally released. It shoves a plunger upwards, physically separating the electrical contacts. An air gap is created, and just like that, the dangerous flow of current is stopped dead in its tracks, all in a fraction of a second, long before it has any chance to start a fire. The circuit is broken. Pretty incredible, right? So let's just zoom out for a second and appreciate the entire journey we just took, from a basic law of physics all the way to a device that actively protects our homes. I mean, just look at this chain of events. It's an incredible engineering story. You start with a fundamental law of nature. Current makes a field. We use geometry to concentrate it. We use a special material to amplify it. And then we use that amplified force to trigger a simple mechanical switch. It's this beautiful handoff from the invisible world of fields to the very real physical world of springs and levers. It's applied physics at its absolute best. And that's really the whole story. An invisible force, harnessed and controlled, acting as a silent, instantaneous guardian inside our walls. Think about it. We use electricity to create magnetism so that the magnetism can protect us from the dangers of electricity. It's an amazing, elegant loop. And it just makes you wonder, doesn't it? What other invisible forces are all around us, just waiting to be engineered into something that could change our world?